So a little project on this fine and warm Saturday morning was changing the tank sender. You can see this is the water tank sender that came out, and yeah, it's not working for a start. It's a capacitive one, and that's not working, which is hardly surprising given the corrosion that's on there. You can see so it sits, I can show you, in there. Probably hard to see, but back there, and there's not much gap, as you can see, so that didn't survive coming out. But the new type's quite nice. So it's this Seamarine or Seamarine, whatever they are, tank sender, and should be it's a radar tank sender, so non-contact. And I've got an adapter plate to go in over where the original VDO 5-hole cutout is. They make all that. And then that will connect straight up to the Serbo GX where the existing sender was connected to anyway, which means that I can get the tank senders on or the Victron system, but also then put it out to MFDs and any other devices on the boat. But I like the fact it's non-contact. I mean, these senders have a lifespan because they live in the water, and the capacitive senders don't last very long. So yeah, we're going with that type, and we're going to do those senders on the holding tank and the fuel tank as well, so everything will be the same, everything will be patched through the same network. So yeah, it's a bit of a morning project, but as always, 2 hours just fighting to get the sender out. Going in should be much easier. Okay, before I go ahead and complete the installation, I just want to talk a little bit more about these senders, why I picked them and what the functionality is, because there are a couple of advantages. For sure, they're more expensive than a capacitive sender, but not a lot more now. The price has come down, and contactless senders, as I said, with no moving parts, they're not sitting in the fluid. It's a lot better. You're going to get better life out of them in theory. I've not tested this. Durability is yet to be seen, but either way, it's using the standard, VDO, whatever it is, a standard 5-hole cutout. So if I need to change it for a different sender type at some point, I can do. But anyway, let's get into the details. So this is the Seamarine STR1. They do two senders, an STR1 and an STR2. The STR1 is what's called an analog sender. It has the different outputs that go into a conventional gauge. And I'll go into those different types in a minute. And here you've got it comes with a really nice instruction manual on it. The instruction manual also includes details for the STR2. Now, the STR2 is an NMEA 2000 compatible sender. So that's really great if you've got an existing NMEA 2000 bus, if you want the output directly onto that, and you want to connect up to the rest of the network. That was an option. I did think about going with that because we are going to be running NMEA 2000 like every modern boat now. However, I went for analog for a couple of reasons. One is I have a Victron Serbo GX, and that will output to NMEA 2000, and I can connect the tank inputs directly to the Serbo GX, and that gives me the access, the ability to see those tank inputs directly on the Victron network. Now we're connected through the VRM portal, so I can see what's going on with the tank levels remotely if I want to. And the main reason for that is I can get them anywhere in the boat. I can just open up my phone if I'm in the galley or the heads or whatever and see how much fresh water I've got on board. So that's really, really easy. I can also throw them out onto the NMEA 2000 network, so they're viewable anywhere, any other display. An advantage, so that's why one of the reasons why I don't mind going that way. If you don't have an existing analog to digital converter, you're probably better off with NMEA 2000. But STR1 are cheaper for a start, so that made a lot of sense as I've already got the existing networks and the configuration and adapters, but also, and you can see these different wires here, and this is a nice feature. So it takes regular power in, has a common ground, and then you have three different outputs, which is nice. So you have a 0 to 190 ohm, which is your standard European sender output on the white wire. The yellow wire is 240 to 33, so that's the standard US spec sender output. And you've got a 0 to 5 volt DC digital output. Now, Victron can take any of those, and all three of those outputs can be used concurrently. So I can use, for example, the 0 to 5-volt output to connect to the Victron, and then the 0 to 190 I can connect to a regular analog gauge, which I'll do and put in the galley, because that's where I'm likely to want to see how much water I've got on board. In the same way that I'll get the same sender for the fuel, the diesel, and then I can have a regular analog gauge up at the chart table or by the helm station to be decided, but I can have that as well as it connected on the digital network. You can use those 3 outputs concurrently. So I could have 2 analog gauges, one US spec, one European spec, and a 5-volt connection connected to the Servo GX, which will give me the output on the Victron. So I think that's really functional, actually. If you want redundancy, I'm a big fan of having redundancy and having multiple options. So NMEA 2000 is one option, and it's very valid. I think for my case, my use case, I would be spending more on the sender than I need, and potentially losing some functionality. So let's see how that works out. The next thing is installation. So these, as I said, are contactless. They actually come pre-mounted with this self-adhesive pad. They are native. They'll go externally mounted on plastic tanks. So if you have a non-metallic tank, they will go directly onto that, and that's really, really easy. Then you can site it wherever is convenient or in the best location. They've got some good, this is just a quick guide, but they've got a really nice installation guide on their website about where to put it and ideal tank locations and so on and so forth. For me, I'm replacing an existing sender, and some other people might be like that. And as you can see, ours is in a pretty tight location for where it is, but there's an existing hole there. Now this is important for 2 reasons. One is we have stainless steel tanks, and as said before, these won't see through. They can see through plastic or fiberglass tanks, but it won't see through the metal tank. So you need a hole, and then they sell as well an adapter. And what happens is you fit the adapter onto the tank over the hole, and then that goes on top of the adapter. If I move the screw down, it fits perfectly on there, and then the sender can see into the tank through the existing hole, and I'm sorted. And because this tank, I mean, this is an older boat, but you can just see it's a cutout, and I just want to show how these work. So this is the inner ring off of the old sender. So how these work with these senders, I mean, it's been around for years, but it's quite clever. So this is a 5-hole non-equal PCD layout. That means the holes only go in one orientation. If you line it up the wrong way, the holes do not line up. But you get your orientation on the gasket and your top lined up with the inner plate, and this little notch here then slides into the tank, and then the whole thing clamps. So this part then goes on the inside of the tank. The gasket and the plastic piece go on the outside of the tank. You can kind of see there. So they go on the outside of the tank, and then you just do the screws up, and it just sandwiches the tank between the gasket. Really simple. It's been like that for years. Most tanks now are coming pre-drilled with the 5-hole. I don't think people realise how much faff and hassle we used to have in the old days trying to get these things to fit. So yeah, it will be a little bit fiddly to get that in and set up, but I actually don't mind those. As I say, and it's what I'm working with, so I'm happy with it. So really, really easy, not expensive, really. They are more expensive than capacitive senders, and the adapter's an additional cost. However, I'm getting loads of extra functionality. The ability to have 3 independent outputs is really, really good. If you have a conventional sender and you want to go to 2 gauges or 2 instruments, you need some either a splitter or a different type of sender with a different output on it. So it's a bit of faff. And if you get an NMEA native capacitive type sender, well then, to be honest, I don't see the point, because mechanical senders are outdated, and why would you have a digital chip on an old type mechanical sensor? It just doesn't make sense to me. So if you're going with NMEA 2000, go with a modern sensor type. And for me, as I said, I already have the NMEA converter in the Servo GX, so I didn't need to spend the extra on the sender, and I get a bit of redundancy. Right, that was enough of that noise. Let's get this fitted. Okay, the install's completed now. Like every boat job, 1 equals 3 and 3 equals 5, because you kind of get to, especially when got all this out, everything opened up. It's might as well just do this, might as well do that. So you can see the senders in there and done, and that was nice and easy to install. So it's super, no problem at all on the adapter. Fit through well, wired in, and then routed through, and it's wired up, as I said before, to the Servo GX. So I'll show you how that looks on there. It's not calibrated yet, but I'll just go through it with you and show you what it looks like. While I was here, I finished up some bilge pump wiring. We're going to have 2 electric bilge pumps on board, and I just want to show you something. So I've got, obviously, this is our 12 volt permanent fuse box. Well, not obviously, but that is a 12 volt permanent fuse box. And all the wires on the boat are numbered. So we've just got a number coding system which I created, and I can show you a little bit how we've got that. So everything is zoned off, firstly. So have just devised zones for the boat, and then there's a master schematic on everything, and then what we've done is just mapped out all the primary and switch and circuit breakers. So everything has a map on it, and then we have a switch number, a wire number, what the fuse rating is, where the location of the fuse or circuit breaker is, and then any details on the wire cable size. So if I need to do any servicing or identifying, pulling things through in future, should make it a bit easier. So the wires are mainly terminated where connections are. So I haven't got or identified where connections are. I haven't got the wires coded in the middle. So we'll see if that becomes a problem. But I think it's just a bit overkill anyway. And then what I have done as well is just kind of mapped. Sorry, that's a bit of a nice bright day, so the sun's on it. But mapped out as well, kind of routings of the wiring, because there's different ways and different options to route the wire through the boat. So just with all the different zones, so where everything is, and I've done that for all the various. So we've got lighting, navigation lights and instruments, lighting, USB and electronics, systems, pumps, so on and so forth. And this is printed off and in a folder as well. So I've got it electronically and in a folder, and then I've got everything from through hull and seacock locations, freshwater plumbing mapped out. Bilge deck and drain and seawater plumbing, pretty much stuff you'd get on a new boat, but this is 1977, so we didn't have this, so I've been making this as we go. Right, so I'll just show you now the app. So when the app's installed, you just pop the tank in, and as I say, it's not calibrated. There is a bit of water in the tank, but that's so it's calibrated itself to 0, but when I go into it again, I can go in and calibrate the tank. So nice and easy. Reset the calibration down there, or what I can do. We've got a tank that is obviously hull. It comes into the bottom to meet the hull. So I'll enter the calibration point. So we'll fill it from 0 to full. I've got some 25 litre containers. It's a 450 litre tank, freshwater tank on this boat. So what I'll do is I'll fill it 50 litres at a time, and then I'll just enter those calibration points every 50 litres. That should give us a nice idea when we go from full to 0. At least we get close. When we get close to the bottom, it won't have a surprise. But then if I come out of there and go into VRM, so you can see as well, here we have the water tank showing there. So that's nice and easy. If I go to the console, so this is now output there. We've got it obviously not calibrated yet, so it doesn't show anything, but that will output onto the VRM portal. Really, there we are, it's doing something. Once it's calibrated, I can show you where we are. We've got about a quarter of a tank, so yeah, anyway, I'll drain it and refill it. But that's it, and then this can output as well to any other device, and I've still got other terminations free, as I showed on the wiring earlier, to put onto a gauge if I want it. So very good, very pleased with it in the end. No issues at all, really easy to install, highly recommended, 10 out of 10. Overall, while we are making progress, some days it's less obvious than others. Today is one of those days. These are the cap rails from here, from this point down here, and they go to that point there. I cut them there because of a couple of reasons. One, I need to take it's right into the lazarette to take off all of the push bit to get the rest off, which I will need to do. But the main issue is because I've had the chain plates that go here and here out, and I've been struggling to dry that area, and I wondered why. So I thought maybe there was water getting under the cap rail, which clearly it has been. You can see that. But also all this bog and wood, which is wet and rotten, that was all filling in this void. So this channel that's here was, so if you can imagine this is flush, if I go to the other side, you can see under there, that area is all just filled up. And so that's all in the channel, and then it was up, and then it formed a really nice little moulding around the scupper there. The problem is, again, if we go look on this side, don't know why I should have stayed on the other side, but hey, it was it was just saturated underneath it. So you can see how dirty it is. It wasn't stuck down as well, it just lifted up really easily. So whatever was, it's a combination of wood and just bog, but that bog wasn't adhered, so inevitably it was going to leak at some point. I guess it's time. These nice bits of wood, I mean, I think this is solid oak or something. Some of it hasn't rotted because it's good solid wood. Other stuff just has been saturated for so long, it's just, like these bits crumbling apart and breaking apart as you take them out. So all needs to be replaced, and then I have to debate what to do with it. I think the obvious, or the first thought at the moment is to make an oak strip around this area here. Oak's pretty good in terms of rot resistance and water resistance, and it's hard as well. That will be a dam one end, and then I could just fill it with some thickened, sort of thickened vinyl ester or epoxy resin. That might be the easiest. The problem with that is the boat's not exactly level, so I may end up making just a paste and then smushing it in and ferrying it out. The other option is to put some wood in there. I'm less inclined to do that because I'm going to have the same problem again in 10 years time or whatever. It's just going to rot out, and it's really hard, it's ferrying all the wood around these areas. Third option is to leave it and have it as clean it up and then paint it, and then have it as an open scupper out to the back of the boat, and then fit the cap rail like it's done on the rest of the boat. The problem with that is I can tell why I know why they filled it, because it's a very narrow gap. I mean, really what it needs is the moulding finishing and filling in there. I could use something like PET foam to space it out, because filling it with resin is just a lot of volume of resin, which is money and weight. Not that this boat matters for weight. So there's a couple of options there to fill it. Whatever I do around here, I need to do solid pours with fibre reinforced, because that's where the stanchions go, and I need the chain plates go, and I need them the right height, because then the shrouds we've got are the right length, and also the holes are right under here at the back. And if I fit the chain plate, it won't let any water drain down there anyway if I fit them flush. So all in all, just another load of work that I found myself to do. Hey ho, that's boat work. So the other job that was done this weekend was replacing the old vents for these nice Vitas mushroom vents. So that matches what we've done up the heads. I've got the one over in the forward cabin to change. But these were just the old sort of solar style vents, the regular ones that, you know, the plastic had all yellowed anyway over the years, so they weren't letting any light in, and also they just don't work very well as vents. I really like a mushroom vent because you can open them up nice and wide. You can see that one is nice and wide to get lots of airflow through, or close them down completely tight and seal them off completely. So yeah, that's much nicer. And then to fit them in, because as every job it's 12 steps forwards and 6 steps backwards, or 6 steps forwards and 12 steps back. It's a boat, right? So one job equals 3. But I 3D printed again with 3D printer the cutouts. So this was this is a cord deck like every other part of the deck on the boat. And what I didn't want to do, because the cutout for these is quite a bit bigger than the other ones, that's another nice thing, lots more airflow. But what I didn't want to do was have exposed core. It did have exposed core previously. Don't really like that because you're going to get damp air through there. So I printed this routing jig, so that allowed me then to do the routing hole nice and square. And then what I did as well is produce this epoxy guide. So this then afterwards slid up into the hole from the bottom, and then I could fill down the edge with resin, and that gave me a nice little edge seal. I didn't get any video of doing it, did it yesterday and I forgot, but yeah, it worked really well. Anyway, so there's a layer of resin there, and then as you can see I've filled all the other holes from the old screws, so I just the rest of this non-skid will come off. I'm going to put solar panels as we've got here on this deck, so when we fit the hatch in the middle, I'm going to put solar panels down each side to get them mounted, and then so we won't need non-skid for that. So then what I'm going to do is just paint non-skid the rest of the areas that needed. Yeah, that was a good little exercise anyway. So next job will be to look at the hatch, because there was an old hatch on here, metal hatch that was leaking, glass hatch with an aluminium frame. This wooden frame that's sort of a spacer between the deck and the polycarbonate we just replaced it with is leaking, it's rotten and leaking. So the whole thing's going to have to come off, but we have got an opening hatch to go in here, which would be really nice. A big opening hatch at the top, which would be ideal for letting lots of airflow through. So happy days.